No other topic fascinates both astronomers and the public quite like exoplanets. What do they look like? Could we breathe there? Is life possible on them? Answering these questions requires us to detect and study the thin atmospheres of these distant objects. The atmosphere of an exoplanet can reveal a wealth of information. By determining the composition and thickness of the atmosphere, astronomers can infer many other characteristics, such as the planet's temperature, the air pressure, and whether the planet is suitable for life. But studying the atmospheres of exoplanets isn't an easy task. Planets don't emit their own light, and they are tiny compared to their host stars. The only way to study exoplanet atmospheres is by monitoring the host star's light as the exoplanet moves between Earth and the parent star, known as a transit. During the transit, a tiny fraction of the star's light passes through the atmosphere of the planet and interacts with the chemical elements therein. Each atom and molecule present in the atmosphere absorbs light at specific wavelengths while allowing other wavelengths to pass. By observing the light of a star during a transit, astronomers can find the fingerprint of the exoplanet's atmosphere in the spectrum of the star. Each element creates distinctive dark lines, absorption lines, in the spectrum. So these lines act as chemical fingerprints, revealing the makeup of the atmosphere. Also, the stronger the line, the more of the corresponding element is present in the atmosphere. But even the strongest lines of the most abundant elements are incredibly weak and hard to detect. Only a tiny fraction of the star's light is interfering with the atmosphere of the exoplanet. Hubble is one of the few telescopes powerful enough to perform studies of exoplanet atmospheres. It also has instruments to collect spectra ranging from the ultraviolet through the optical to the near-infrared. This is crucial to fully characterize these atmospheres. In spite of Hubble's capacities, the analysis of exoplanet atmospheres pushes Hubble's instrumentation to its limits. The telescope can only detect the strongest lines from an atmosphere in a given spectrum. It's enough to give us an idea of the composition of an atmosphere and the appearance of a planet, but it is not possible to reveal the fine details. While Hubble will continue its studies and will help to advance our understanding of planetary atmospheres, astronomers need bigger and even more sensitive instruments to detect the weaker signatures in atmospheric spectra. The forthcoming NASA-ESA CSA James Webb Space Telescope will deliver exactly that.